Let's get started. I would like to introduce KYZEN Scott Cain.
Good morning, or good afternoon, or good evening, or whatever it is in your world. We thank you guys for taking a few minutes to hang out with us, and hopefully you find this informative, learn some stuff, and maybe we get a smile along the way. So what we're going to be talking today is OA fluxes and how we can avoid the foam in the tank, and then kind of what happens if we do have foam, and how we can alleviate that and any issues going forward. There we go. And this is dealing with the unforeseen challenges. So first off, we're going to talk about what's the first four-letter F word that comes to your mind. Don't say that one. Don't say that one. We're in a family environment. We're going to just talk about today's four-letter word is foam. And what we're going to do is kind of think about, so when are the times that foam is good? Getting a shave and washing your car? Absolutely. Either a latte or maybe a beer that's got just the right amount of head on it. That's great. If you've ever worked a trade show, you know that foam under your feet is a great thing, especially on that third day when your dogs are barking. It's good to have that foam under your feet. What about when foam is bad? You got a dog with rabies, somebody has poured a beer with way too much head on it, or you've got foam coming out of various appliances around the house. It is definitely not a good thing. And of course, per our conversation, what we're going to talk about today, foam is not good when we're talking about cleaning our circuit boards and in the cleaning process. So let's take a step back for just a moment so we can kind of bring this all together as we move forward. So what we're going to talk about is, specifically on the organic acid flux residues. So just to let you guys know, we do these tech to tech conversations every 2 weeks. And earlier, Eric Miller put together one on foam overall. And that can be found on our webpage with all the other tech to tech presentations that have been provided. But this one today, we're going to talk specifically about organic acid flux residues, the OA fluxes. These are historically much stronger than the rosin-based fluxes that some people understand and use. And they contain the polar ions that are removed by a polar solvent, such as water. They always are cleaned, and one of the main things with the OA fluxes are they need to be cleaned quickly. Some of the other fluxes that are out in the industry, they can stay on the board for a longer time period. But with the OA fluxes, we need to get them cleaned off of there in a very quick manner, or else they create issues going forward. And let's talk a little bit about how the cleaning machine works. And really, there's some variances between an inline and a batch machine, but really what it is it uses high pressure pumps in wash and the rinse sections. And keep that in mind about the pumps. That's going to come back in just a couple moments. And the nozzles turn the water over every 30 seconds. One of the things that happens is foam eventually shuts the process down. It can leave a mess if that foam occurs inside of the cleaning machine. So let's take just a moment and think, what would happen if we mix these things, right? We've got some dish detergent that we use for washing dishes in the sink, a blender, and then just some water. We throw those in on top of the counter, press the blending button, and off we go. Well, we're going to have lots of foam. And we're probably going to have a very mad spouse or roommate that is wondering, why are we doing this? Because foam is going everywhere throughout the house. So why do we bring this up? Because this is actually kind of what happens with the OA fluxes inside of a machine if we don't have the process optimized. Similar to if we have the wrong, we don't want to use that Dawn in that application because it's going to create so much foam and it's going to create more and more. Same thing with this. If we don't have that process optimized, then what's going to happen, and this is a really key point of this presentation, is the OA flux surfactant will build up and it'll create that excess of foam. So what we're trying to do is find a way to control how much of that surfactant builds up. We want to be able to control what how much we have in there so that it doesn't continue to build up, therefore creating the foam. So why are we avoiding foam? The first thing is it can exit the machine. It can leak out of the machine. It creates a mess. It halts the manufacturing process. Really, the only good thing that comes out of that is you're going to have a super clean floor. But as you guys know, with anything with water, foam, etc., it's going to find the path of least resistance and it's going to go everywhere. So we definitely want to avoid that. Second, issues with the pumps. We talked about pumps a couple minutes ago. What can happen is if there's foam inside of there, the pump thinks it's actually full of liquid and water, but it's not. It's got a mix in there. And so what's going to happen is that pump is eventually going to cavitate. Therefore, you're not going to get the pressure out of the nozzles onto the board that you're looking for to get that impingement factor. Additionally, it could have long-lasting effects on the pump, and it could damage it and have to be replaced, which means that the line is down, you're costing time and money to replace that pump. Additionally, foam is bad when it comes to the float switch. So the float switches are inside of the machine. They're supposed to stay at the bottom and the top and kind of make sure that we have the right amount of water or chemistry inside of each individual tank. And what happens is foam for a float switch feels like water. It's going to engage any sort of float switch that's on there, but it's really not, right? Because it's just the foam. So what happens is that can engage that. It's going to stop the machine. Again, we're going to lead to an interruption in the production process because the machine is under an impression that is incorrect, that is caused by the foam. And finally, what about the cleanliness required? That's why we're all here. We're trying to get the clean boards. We're trying to make sure that we're hitting the specifications that we either internally as an OEM or externally as a CM are required to meet. And what can happen is the foam decreases the ability of the water to get below the parts, and it usually won't clean under 3 mil parts. And if we're not able to hit the requirements that we're looking for, now we're going to have to clean again because there's too much foam inside of there, or look at a secondary process, which again, time, money, all these things that are affected and cost your organization money because of this foaming issue. So let's think about how to avoid foam, right? We've already said foam's not cool. It's kind of the 4-letter word. Like, how do we avoid it at this point? So foam begets foam. We kind of talked about that a minute ago. And what happens is it needs to be removed and replaced with water to control that level. We need to make sure that we're pulling foam out, replacing it with water to make sure to keeping in that safe space. What happens is each machine is manufactured differently. Machines are made for chemistry applications, made for water applications, and then made for both. And if you're having this problem, one of the things to do is reach out to the manufacturer of your machine to determine if it's built for that application. Additionally, any of your local Kaizen sales managers, regional managers, etc., can assist with that. We can take pictures and videos, send those in, and we can look at them as well. But we want to make sure that the machine is actually designed and built for those applications. So obviously, like, hey, we're Kaizen. We're kind of known as chemistry. So obviously, there is chemistry evolved that can do this. All of your cleaning chemistries in the industry have a built-in defoaming agent. What we can do is those chemistries can be specified based off of your application and remove the possibility of foam. One of the key things is to make sure that your concentration is high enough. If we see foam, a lot of time it is from the fact that the concentration is too low, but really we're just wanting to keep that concentration above maybe 3, 4, 5%, and that'll have enough of the defoaming agent that is built into the chemistry in there to eliminate the problem of foam. Another thing is there are defoaming agents, and these need to stay at the top of the wash tank to be functional. So that's kind of that cascading motion that we talked about in the inlines where there's water coming in, water coming out. We need to make sure that the defoaming agent stays within that portion of the machine. Kind of to bring it on home, what's the difference between these two, right? They're both going to clean your dishes. There's going to be bubbles with both of them. But what you're looking at is what they're built for in terms of the application. Also, we don't advise eating or drinking any of these, just because we've heard there's a little bit of that going on in the media, and so we want to stand behind not having that go down. The dish soap on the left is going to be used for hand wash application. The dish soap on the right, the little pods, sit inside of your dishwasher. If you switch these over, you're not going to get clean dishes in either application because they're not built for that. It's really what we're looking at. Let's make sure we're finding the chemistry and the application in alignment so we're not going to create more of an issue because we don't have complementary process and product together. So in conclusion, the foam can create issues in the OA flux cleaning process, right? We talked about that. It's going to cost in terms of time, money, board quality, your sanity, all those things. You want to make sure your machine is designed for the OA and the water applications. And chemistry is available for these applications to remove the chance of foam and increase those cleanliness results that we were looking for those under 3 mil parts. And finally, hey, we're here for you guys. This is what we know. Our team, we're kind of an extension of your engineering department to discuss your cleaning applications. You guys have to worry about SMT and X-ray and AOI, and I know all those are just acronyms, and I can barely spell those, much less know what's going on with those in your plant. But our team, we really know cleaning, and we'd love to talk to you guys about this stuff and kind of assist in the process and just become an extension of your engineering department. Just so you guys know, we do these every 2 weeks. We really appreciate you taking a couple minutes to hang out with us. And just to let you know, the next topic will be done in 2 weeks by Kevin Buckner out of the Southwest. And that's going to be on what you need to know about flush mount component cleaning. So I thank you guys for spending a couple minutes hanging out with us this morning, this afternoon, this evening, whatever time it is in your world. And if there's any questions, go ahead and send those in, and I'm going to pass it back over to Sherry.
Thanks, Scott. If you would like to discuss this topic further, please contact your local KYZEN representative or send an email to tech@kaizen.com, and we will have one of our cleaning experts schedule a follow-up with you as soon as possible. Again, we thank you all for joining us today, and we hope to see you again soon. Stay safe, stay healthy, and have a great day.